Welcome back. In the previous video, we've created a login table. Now that we have these two tables together, I want to show you the real power of relational databases. Going back to our drawing, the most important part of relational databases is this idea of schemas, of having tables that are just concerned about storing information specific to them, such as users, tweets, and following, and connecting them through a primary key and a foreign key. I'm going to show you how to do that. Well, we've already done it, but how do we grab information from it? If we go back to our table, we remember that we ran our query we've created the create login table here, and we created a name variable that, when we planned this, was going to match whatever the users table had. And we can use something called joins now with our queries. And this is a new word in SQL and probably one of the most powerful. Because we don't necessarily want to have one massive table with hundreds of columns, hundreds of rows. Databases aren't designed to just have, just like an Excel sheet, tons of rows and columns and have all that information in one place, because it's not efficient. It'll be a lot slower. It'll be really, really hard to manage. And the bigger and bigger your company grows, it's going to be really, really tough. A good way to design a database is to have these small little tables that are just concerned, just like separation of concerns, concerned with their minimal needed information. And if something else is needed, we can just join tables together to grab information. Let me show you what I mean. We have over here our test database. And let's do /d to see. All right, we have three files here. We have the login and users, which we created, but what is the login ID sequence? Remember how we created a primary key? The way relational databases work is when you create a primary key, it creates another file that contains this primary key. And you can see that the type is sequence. Now, this is a file that most likely we won't access, but internally, Postgres is going to make sure, because we set this primary key, it's going to be really, really fast to grab data from the login table when we request it. But let's say I wanted to get information from login and users. Perhaps I want to get Sally's information, but I need her birthday, score, age, as well as her secret. By using joins, we can do this. I can say select star, so everything, from users. And now if I do join, I can say another table name that I want to join with the users, in our case, login. And we have to say on, what are we going to join it on? How is it going to know what matches with login? Because if I go back here, how's the database going to know that I want to match the first line with Andre, the second line with Sally, the third line with John? The on keyword allows us to make sure that we match on something. In our case, it's the name, the primary key here, and the foreign key here. So let's do that. On users.name equals login.name. Semicolon, let's do that. And look at that. We have name, age, birthday, score, but also ID, secret, and name all together. We've just joined these values and they all match because we've done login.name and user.name. And with joins come great power now. We can have small little tables based on what we actually need. And anytime something specific is needed, we just join tables, and you can do multiple tables, multiple joins, in order to select the information that we need. All right, I think we've done a really, really good job understanding SQL and the power of relational databases. I'll see you in the next one, and good job getting this far. Bye-bye.